So we begin with the terminology of a parameter. That t variable is our parameter and is usually defined over an interval of real numbers. We call that the interval of the parameter. If it's a closed interval, it has a definite real number beginning and a definite real number end. For our graph, we call the initial point the point that we get by plugging a into our x-coordinate function and a into our y-coordinate function and plotting that particular point. The terminal point is, of course, the point that you get by plugging the last value of t, that is b, into your coordinate functions. So a parametric equation together with this interval is called a parameterization of a curve. And as we saw in the previous example, you can have two different parameterizations that describe exactly the same curve. And in this next example, we'll give you an idea of how to graph a parameterized curve. Generally speaking, you want to choose t values that give you all the interesting points inside of here. This is a quadratic equation for the x-coordinate. So if you remember, a quadratic equation or parabola relationship has a sort of turning point. Once you go away from the turning point on the left or the right, it kind of does the same sort of thing. So as long as you get the turning point, the max or min relative to this description over here, then you'll probably get enough information to plot points to get the interesting parts of the curve. Luckily, the y-coordinate is just a linear function. It's kind of the same pattern everywhere, so you don't have to worry about where the interesting point is there. And notice we have our t begins at -2 and it ends at a +2. So we'll want to know what the initial and terminal points are. We can use a table with a t value that we plug in along our intervals, and we find the corresponding x-coordinates and y-coordinates that we plot. So for the first row, we replace our t inside our equation with a -2 and we evaluate. We do the same thing for our y-coordinate to get our initial point that we will plot. Our initial point when t equals -2 has an x-coordinate of 0, so it should be on the y-axis, and a y-coordinate of -4, so I plot it over here. When t equals -1.5, we evaluate our x-coordinate to get a -1.75 and our y-coordinate to get a -3. Continue evaluating to get our coordinate pairs of x and y's throughout the table. And I plot the points as you see here. I've filled in the rest of the points here by using the coordinate equations to calculate them. And I plotted the points over here. So the thing to notice is that the coordinate equations are continuous functions. So I should probably connect these dots with a continuous curve as best I can. And this looks like a parabola turned on its side. If you want to graph a curve in GeoGebra, you can specify your function separately by using the same notation you'd write on paper. Then there's a curve function, and the way you write it is you start writing the word curve. You have multiple functions to choose from, but we're only doing 2 coordinate systems, so I'm going to enter over here. Then you're specified as your f of t. You write it for your first expression. That's going to be your x-coordinate. Your g of t is going to be the equation for your y-coordinate. The parameter you want to use is that t. You have to say where you want this parameter to start, the t value to start. In this case, I want -2, and I want to end at 2. Press enter, and it graphs it for you. Now I made a side parameter t. There's an option to do that if you want to see it. And I made it so that you can see a point moving. Notice that I have r of t. That's this function over here. I plug in the t parameter. That's this number over here. And it does the calculation for me to see what the values are. If I want to animate it so you can see it moving, that is how the particle moves along its path.